Hello everyone, can you hear me? Okay. So, good afternoon. And my name is Mohammad Abul Bashar. Some of you already know me. And today I'm going to talk about generative AI and large language model. So I'll be covering basic concepts, some of the applications and future directions. You know that large language model and generative AI, they belong to artificial intelligence, and so artificial intelligence has machine learning as subfield, and then in the machine learning we have deep learning. And then with the emergence of deep learning, we have large language model and generative AI. And then in the generative AI, we have number of tools. So for example, we have visual tools that we can use for generating image. Say video generator and image generator, and then we have audio tools that we can use to generate music or some voice and so on. And then very common or very popular ones are text generator, that it can generate some essay or can respond to your questions. And then also we have other components that can generate programming codes. So for example, you can ask it to generate Python codes and then it can generate it. So large language model is referred as general purpose large language model. Why general purpose? Because you can train a large language model and then you can use it in many applications and domains. So the essence is that because the language itself, wherever you are using it, has some common features that are shared in different domains and tasks. So for example, if you have a pet, and then you train it with some general instructions. So for example, sit, down, stay, come, or run, right? So those basic instructions are enough for a pet. Now if you want to use that pet for special service, so for example, police dog, guide dog, or maybe a hunting dog, then you will need to add or train additional instructions so that it can do those specific service. Now, if you want to train a dog from the beginning, it will take long time to train all these things. But if you have a say pet dog that already knows those basic instructions, then it will be easier to take that pet dog and add some additional instructions, and that it will be a special dog, right? Similar in large language model, we train it for a large language model using different data sets and in different domains. So it captures the basic intuition and grammar and features in a language. And then if you want to use it for a special purpose, so for example, conversation or summarizing or question answer generation and so on, then you can fine tune that model using extra label data that will serve the purpose. And now the question is, why large language model? Why large? The large part comes from two things. One is the model itself is very large, so it has a large number of parameters, and then also it is trained on a large number of data collection or petabytes of data, right? So some examples are like GPT-4. So GPT-4 is trained on by using 1.76 trillion parameters, and it has actually 8 submodules. Each of them has 220 billion parameters. And those submodules are actually connected with mixture of expert model. And then you have PALM. PALM is, it has 540 billion parameters. It is called pathway language model because it uses a pathway technique that allows this large model to train on number of different machines. So parallelization is easier if you are using PALM. And then you have Falcon. Falcon is open source. It has 40 billion parameters. So if you are targeting to customize a large language model for your organization, maybe it is a good idea to start with Falcon and then customize it for your organization. So what is the benefit of using large language model? As I said, because it is general purpose, so you train a single model and you can use it in many applications and domains. So for example, you can use the same model for language translation, text classification, question answer, and so on. And if you are targeting it for fine tuning for a specific domain and task, it will take a small amount of data. And sometimes you can use few shot or zero shot. So few shot means you just use a small number of level data, change a little bit the model, it will work. Or you can use it for zero shot. So zero shot means you don't need to train the model, or you don't need any level data. You just simply take the large language model, and then you take its representation or vector, and then you use cosine similarity as zero shot to classify new things. Another advantage is if it is a large language model, and then by increasing the model size and training data, you can easily increase the accuracy, which is not usually possible in other classical models, for example, SVM or so on. So that is a big advantage. Another thing is large language model looks like, because it is language model, it may be only for text, but it turns out that it is useful in other area as well. So for example, if you want to instruct a model to generate an image or something, to generate code or something, then the model needs to understand what you are asking for. So that you ask it through natural language, so the model needs to understand that natural language, convert that in the instruction that is understandable by say image generator, and then instruction will be sent to the image generator, and that will give you the generated image, so on. So that means large language model is connected with other models as well. So here I'm trying to explain in a very layman and very simple way how traditional machine learning and deep learning and large language model they work, right? So in traditional programming, we give some, say, transactions, and then we want to know whether it is a legitimate transaction or not. So we need to define some rules. So our program will check each transaction against the defined rules and see if there is anything anomalous, and then flag that transaction as fraud, right? In the machine learning, we do not give the rules. We give the transaction and whether it is fraud or not. And then machine will learn those rules. And then if you give the new instance, then it will use the learned rules to justify or detect whether it is anomalous or not, right? Then in the machine learning, we have like discriminative model and then generative model. The difference is very subtle. They are not actually significant difference. Other than that, usually generative models are very large, right? So in the discriminative model, what we have is, say, you have cats and dogs, and then you, for each cat and dog, you map it to a, say, some latent space. And then you try to learn a hyperplane that can separate the cat space from the dog space. Now, if a new instance come in, it will map it to the latent space and see whether it is in the side of dog or in the side of cat. If it is in the side of dog, it will say it is a dog, otherwise it is a cat, right? In the generative model, when you give an instance, it tries to learn manifold. So that means it will try to learn some small subspace where each space will represent different things. So for example, one space for cat, one space for dog, right? And in the cat space, you have different color of cats, different variety of cats. So if you move around this in this space, as you move, the color and the different properties of cat will change. And then if you move to the dog space, that will give you the dog. And then if you move around in the dog space, you will get different dogs with different properties, right? In a very simple mathematical term, you can say in the discriminative model, given a data set X, you are trying to predict what is the probability that this data set belongs to cat or dog, right? You're directly trying to map this data point to a class. On the other hand, if it is a generative model, you are going to predict the probability of a data point generating from a distribution. So for example, if a data point is given, you are trying to predict whether this data point is generated from the dog space or the cat space, right? So you have the you estimate the probability of X given Y. That means X is your data and Y is your data, your label. So you are saying, what is the probability that this data point is coming from dog space or this data point coming from your cat space? So if you know that probability, you can simply use Bayesian rules to change it, probability of Y given X, right? Then you can use it for classification as well. So you train a generative model and then you can change a little bit in the model and then you can use it for classification. Okay, so the question is how those models are trained. So if you ignore all the complex details, you can simply think about a transformer model, because like transformer model is a very common technique used in generative model, also in discriminative model. So the whole model, the whole transformer model, it has two parts. One is called encoder, another part is called decoder, right? So the left-hand side, you can see very simple one, but if you want to see a little bit more, you can see the right-hand side figure. You can see in the right-hand figure that it has multiple layers of attentions. So it is not that complex actually theoretically. It is very simple. The idea is very simple. So you have attention, and then you stack multiple layers of them, then you get the model. Now you can see there are two parts. So one is encoder and the decoder. So if you are using for translation, for example, you give an English sentence, it will encode that sentence into a latent space. That part is encoder part. And then the decoder will take that latent space and decode into a different language, say Chinese or French or so on, right? Now you can see that there are interesting things about these two parts. The first part is more effective when you are trying to represent something in the latent space. So that is encoding. And therefore, you will see, say, BART or some other models, they are discriminative models usually used for, and they are very good to represent a data point to a latent space. So how they are trained? Given a sentence, they try to predict. So you give a sentence, and then you intentionally remove some of the words from the sentence, and it tries to predict those missing words, right? And then the decoder model. So decoder model is good for generation. You give some latent space, it can generate. So for example, GPT-4 and so on, they are generative models. So you give something, instruction or something, they can generate a lot of things, right? They can generate essay and so on. So if I go a little bit more technical, so you can see that in the encoder model, you have self-attention, and in the decoder model, you have masked self-attention. So in the self-attention, because you are not concerned about generation, you are simply trying to map this one to latent space. So if you give a sentence, it will see the whole sentence from left to right, everything it will see, and then it will calculate this attention score, and then that will be used or represented in the latent space, right? Then you can use it for different tasks. On the other hand, if you are using generative model that uses actually decoder only, so in the decoder, because you are generating, so for example, given some words, you are trying to predict the next word. And so for example, if you are given in a sentence, you have 10 words. So you are given 3 words, and then you are trying to predict the 4th word. And then you take the first 4 words, and then you are trying to predict the 5th word, right? So in any given time point, you can only see that point and the previous point. So you cannot see the future one. If you see the future, that model will not work. So you can see it will use masking technique to block the future words, so that it can only rely on the first or the present words and predict the next future word. So large language model is actually nothing. It will always, in an iterative fashion, it will simply predict the next word. Given some words, predict the next word. You add that word and then predict the next word. It goes this way. And you can see in the structure that in the encoder model, the sentence goes to the model, or the instance goes to the model, and it can analyze all of them together and then gives a latent space. On the decoder only model, you can see at each time point, it can only see this point or the previous ones only. That's why you can see the arrows only goes to the right, not to the left. Okay, so if you are using large language model, there is some difference between traditional machine learning development, right? So if you are using large language model, it is easier to develop than if you are using traditional approach. So for example, in traditional approach, you had to be ML expert to train a model. You had to know what is the architecture, what data you need to use, and so on. But if you are using large language model, you are simply, because say GPT or some other models, they are already pre-trained. You use their API and then use it for your tasks. So you don't need to be expert in machine learning. And because traditional models, you start from the beginning, so you need lots of training data. On the other hand, large language model, it is pre-trained. You don't need any training data. No need for training. in the large language model area. And in the traditional language model, we concentrate on how to optimize the model by using the loss function, right? So you design a loss function, and then you develop, say, some algorithms that can optimize the model for that loss function. On the other hand, if you are using large language model, you don't need to concern about those things. You simply need to know how to instruct the model, and we called it prompt designing. So your prompt, that means your instruction should be clear, concise, and informative, so that the model can easily understand and give you the and follow the instruction or give you some response. And if you look into the traditional deep learning or machine learning model, they are task specific. So, for example, they can be used for to detect misogyny in online or some other thing, right? On the other hand, if you are using large language model, they are general purpose. So you can ask them to do anything, then they will try to do those things, right? Okay, so one example of large language model can be question answering. You can ask it some questions, and then it can give you the answer. Okay, so some examples here. So in this first example, I am using actually Bing ChatGPT here. So I said, if each storybook is $20, I have $50. How much I need to save to buy 3 books? And then it will give you answer. But you can see that it not only give you the answer, it also gives you the sequence how it concluded that answer. So it says, okay, to buy 3 books, you need to multiply the price of 1 book by 3, and then you get $60, right? And then you have savings of $50, so you subtract 50 from 60, then you need so additional $10, right? So it gives you how it concluded that answer. And then I asked it, can you generate the Python code to solve this problem? So it says, if each side of a square field is 10 meters and each tree planting takes 40 square meters, how many trees I can plant in the field? Can you write a Python code to answer this question? So you can see it writes down the Python code. Also, why or what each instruction is doing, it is explaining. And then you can see that in the third example, I said, can you draw a picture of Thor teaching generative AI? And it generated 4 options for this. Okay, now because you can see that in large language model, our concern is more about prompt designing and prompt engineering. So what is prompt designing? Prompt designing is simply writing down clear instructions so that the model can understand. And the prompt is task specific. So you need to say, okay, can you generate this Python code for this, right? Those things. So you don't need to be specialized in any domain or how the system works. And usually these kind of things are dealing with general concepts, and usually they are effective if you are dealing with in general area. And obviously, if you are going to use a large language model, you need to write down those prompts, right? On the other hand, prompt engineering works with how to optimize those prompts so that the model gives you the best answer or the more accurate, right? So to do that, you need to know a little bit about the domain, and also you need to know how the model itself is working or how it is trained on, what data is used for training the model, so on. So that means you need to be very special to optimize prompts. And another thing is, if you are targeting for more accurate or a special domain, then prompt engineering is actually required. We can categorize the today's large language models into 3 types. The first one is like basic ones, where they train, say GPT-4, they train a model. It will simply predict the next word. So it will, you give something, and then it will, based on that prompt, you will generate something, right? And the second one is question answer or instruction tuned. That means you give an instructions, and then it will try to follow that instruction. So you can say, okay, given this text, can you generate a summary? Or you can ask a question, you give a text, and then related to that text, you can ask a question. and then it will try to give you the answer, right? And the third one is conversational. So in conversation, whenever so you not only ask one question, you ask multiple questions. So you ask a question, it gives you an answer, and then based on that you ask another question, and then it gives you another answer. But it needs to remember what answer it gave you before, or what question you asked earlier, right? So if it cannot remember those, it cannot answer it correctly. So that needs to follow some steps, right? Okay. So now you can see that if you remember this part here, when I asked to do something, it followed some steps. So this is called actually chain of thought. So when you ask it to do something, it tries to use chain of thought. So it actually breaks down a complex problem into some sub-problems, and then it tries to solve those individual problems and then combine them together to give you the final solution. You can follow, so if yourself you are trying to solve a complex problem through large language model, you can break down your problem into some sub problems, and then you can give detailed instruction of how to solve each of them, and then you can get better result. So here, for example, you can ask it a question like, in what country was lost gravity manufactured? And then it will try to search the internet, right? And you can accumulate some documents. Based on that, it says okay, the lost gravity was manufactured by Mack Rides. So, but it is not the final answer. And then it goes again to the internet and accumulates other documents to see, and it finds out that Mack Rides is a company from Germany. So the answer will be Germany, right? So it will use chain of thoughts. So chain of thought is very useful in large language model. When you are giving instruction or it is producing the instruction, it will make the answer more accurate. So you can see that because they are general purpose, obviously they have some problems. So if you are expert in everything, maybe you are not expert in anything, right? So they are usually good for the general purpose, but if you need to use it for any specific purpose, then you need to fine-tune that one with some label data, and then that will give you better or more accurate result for that specific domain. So now I'm going to give a case study that we did with GSQ. GSQ is actually a Geological Survey of Queensland. So they have like different coals, minerals, and those mining documents, scientific documents. We tried to see if we can use ChatGPT or those large language model to interactively find questions for our answers. Find answers for our questions. So the idea is in general, like currently or in the general area, what we do is if we want to get an answer for a question, you need to analyze different source information. So for example, you need to go your emails, your social media, or your database, and so on, right? You analyze all those things, you accumulate those analyses, and then give the final answer. In large language model, people are thinking that it will be the case that in the middle it will be large language model. So you ask a question to the large language model, it will analyze all these sources, combine those analysis results, and give you the answer. So it will alleviate a lot of your burden and make your life more maybe relaxing. Okay, so here we give an example how we try to do this thing, right? And we use actually LangChain, a Python library, to do this experiment. So we gave some initial prompt. In the initial prompt, we said how the language model or large language model should behave. We said, suppose you are an expert in geoscience data and so on. And then we said, okay, your task is to extract some information from a context. If you know the information, or if you can find the information, give it in a bracket, the value. If you cannot find it, then you say not available. And then we give the context. That means you give a document or some documents. And then we define a question. Question is actually type of information we are searching for. So we said well purpose is the primary intended function at the time of drilling of the well. Right? So we define what kind of information we are looking for. And then we said, okay, can you extract the well purpose from the context? So this is our question. And then ChatGPT gives us the result that it explains how it, what it thinks about the question and so on. And then it gives the answer to produce gas from the Walloon coal seam in the Combebula field, right? So this is the answer. And then I asked again, explain where do you find the information? And then it gives you the explanation where it got the information. It says, I found the information in the first sentence of the text, and then explains what, right? Now, let's see what those, and as I said, we experimented with large number of scientific reports from GSQ, and each document looks something like this. So it has some tables, and then if it is table, it is easier for a large language model to find the answer because it is a bit structured. But it can be plain text. So in that case, it can be a little bit more difficult. We had like 16 different types of information we were looking for. Some of examples were like well name, current class, well purpose, operator, and so on. And they are actually large documents. This is just a small segment from the document. So this is our workflow. So we had these actually historical documents. They are in paper format, right? So we had to, the organization, they took, scanned them, so like picture, and after scanning, and Thiru and his team actually, they OCR'd those documents. So after OCRing, we end up with some docx file, right? And because each document is very large, and the large language model, they have limitations. They cannot take actually very long document. They have a predefined size limit. So we had to split them into multiple chunks, right? So in the splitting, we had tables and text. And then we used those table and text to find those information. And so we had ChatGPT that we asked to find the relevant information. But the problem with ChatGPT is because it can hallucinate. That means it can give you information that actually doesn't exist, or wrong information, right? So we trained another model, BART question answer system, which is actually specifically trained using our domain data to see how they perform, right? And how to guardrail if the ChatGPT is hallucinating. Another thing is actually because not all the text segment has the answer for the question. So if it doesn't have answer, then potentially our model can hallucinate. So what we did is we trained another classifier that will tell us whether the answer is there or not. If the answer is there, we keep it, otherwise we discard that segment. Now we send the remaining ones after the filtering, send them to BART question answer system and ChatGPT, and they give us key value pairs. That means the question and the answer. And then we do the analysis and see what is their performance. To train the BART, so the BART part, like BART question answer system, the input was something look like this one, right? So you have like context, and then you ask the question, and then you have the question like answer. So answer is actually, because it is extractive model, you have the BART will actually give you the starting and end character of the answer. So you search through the text and then extract that part. And here is the experimental result. You can see that our BART model giving a little bit better result than ChatGPT. The reason, as I said, because ChatGPT is general purpose. So for a specific domain and task, it may not work as well as a specifically trained model. Now, another thing is, as you saw that we use classifier as a filtering. So if you use the classifier as filtering, you can see that the accuracy further increased significantly. We also tried to use document level aggregation because each document is split into multiple parts. So your ChatGPT may give different answer for different from different segment, even though the answer should be the same one. So we tried to see what answer is most common, and we took that common one. And you can see that by doing that, ChatGPT increases its accuracy, but BART doesn't increase that much. The reason is BART already is consistent. The ChatGPT was not consistent. So it looks like it is useful. So in the future, maybe it will come a time when you can simply chat with your data or your documents using large language model. But whenever you are using large language model, you need to be careful. So you need to be careful about violation of data privacy, because when you are using in a like conversational manner, if you are giving some personal information, you need to know whether the model is storing that information and training the model. So if it trains the model using that information, in certain point, it can actually reveal that information. So there will be privacy problem. Another thing is intellectual violation of intellectual property. So if you are giving some input, if it is using that input as a training, so maybe it will violate the intellectual property. Another thing is because large language model are trained with different poetry, literature, and so on, and also say DALL-E and other image model, they are trained with different artwork. So the question is who will be the responsible for those intellectual property. Another thing is if you are using it, sometimes it will actually, if the training data, they do not have enough data in the, when they are training, it simply can copy paste some source. So for example, if you are asking a question or asking to do some specific task, and it doesn't have enough information about that and only one source of information, it can simply copy the whole thing. So that will actually violate the academic integrity. So whenever it gives you an answer, you need to search that answer using, say, Google to see if it is copy pasting from somewhere. So if it is copy pasting, you will need to change it. Another thing is by design, it is supposed to be mediocre because it is trained with the whole data on the internet. Some of the data is high quality, some of them are low quality. So if you take the average, it is mediocre, right? So you need to be careful that it is never going to be very accurate or spatial. It will always be mediocre. So another thing is hallucination. So if it is hallucinating, maybe you're asking some question and it gives a nice answer, but the fact may be false. So you need to be careful. Another thing will be because now you can, within 10 minutes you can write a blog, or within half an hour you can write a research paper using ChatGPT, right? So you need to be careful that most of the information in the online that might be generated by some generative models. So they might not be that reliable. So now we need to be more careful when we are accessing internet. There are some guardrails. Some organizations, they are implementing guardrails. So for example, Bing as well, they have their own rules. So when you ask a question, they check that question against those rules to see if there is anything that violates those policy. And then if it is okay, then it will send the question to the ChatGPT or the large language model. And then the ChatGPT will generate a answer or response, right? And then it can check that generated answer against some other rules. And then if it feels that the answer is safe, it will send it to the user. According to Bill Gates, he thinks that within 10 years, ChatGPT kind of models or large language model is going to revolutionize the way we are doing things. So especially education, right? So different people, they have their own style and interest in different things. So if we are using large language model, they can learn our interest and our style of learning. And then based on that, it can customize the answer, and then we can use it. But it is needed to be warned that always, if we are using large language model, we need to be critical to accept the answer. It might be wrong, so we need to be very critical. And also, right now, the stage the large language model is, they are mediocre, so you can only use them for some general purpose or say low risk task. And it can increase your productivity, but it still is risky to use them in mission critical project. Thank you very much. If you have any questions, I am happy to answer them. Any questions? Okay. Yeah. training?
Training the model
Yeah.
based on the context, and you are getting answer from the context.
Yeah. So,
So
but the ChatGPT part, I didn't train it.
yeah.
Only the BART model I trained it.
So how do you define this is the context that you have to look for to find this question answer?
Oh, okay. So in the BART model, they have like it uses a separator. So the first part of the text will be your question, and the separator, and then the context. So that is the format to use. So this is actually the input format that we send it to the BART model. So you can say you have the context and the question. So it will generate the answer or extract the answer, then you will check against the ground truth.
So you define the context which one to use as a context.
So there is no like specific way of defining it. It is simply that you use a separator. So and then if you train it for many iterations, then it knows that okay, this is the point of where it is the question part, and this is the answer part. Yeah.
So you have some labels already.
Yeah. Yeah. Yeah.
Who is the training for the elements that the AI should not say, like how to destroy the humanity, or I don't know, how is that training made?
Sorry.
How is the training made for the answers that the AI should not answer?
Oh, okay. Yeah.
Destroy
So
humanity or
yeah.
suffer the drugs.
Yeah. So it is difficult to like make sure that it will not answer, but there are some things. So for example, here when we defined here, we said okay, you should be behaving like this. So you can say okay, you should not generate anything that goes against some race or maybe some gender, something like that. You can define those things. So usually if you define those things, it will try to follow, but sometimes it breaks. So that's why you have extra layer of checking where you will check if it is safe or not.
But it's not something fixed, because I remember like ChatGPT some time ago, like my grandma used to tell me Windows keys, and I don't know, like key for registration, and
Yeah.
they just told like.
Yes. So when you are fine tuning, so what Bing is doing is whenever you're using, you can actually give the feedback whether the answer is acceptable or not, right? So they will actually record them, and while you said they are not acceptable answer, so they will use those as well to emphasize that they should not produce this kind of answer, right? So that will bias or push the model to behave more accurately. But still, because it is generative model, still it can generate something wrong. So always there will be some layer that will need to guardrail against those things.
Yeah, and in the same line, like AI is going to like doing connections already, like with sockets, I know with IoT and like that kind of devices.
Yeah.
How they are constraining again, like the access.
Yeah.
Like,
So yeah. So
it's like a machine with a machine.
yeah. So there are many philosophy how it will be doing. So in Bing architecture, you can say, or ChatGPT, they have actually multiple models. So when you ask a question, it try to understand what the question is about. So if you are asking for generating some Python code, so it will forward that question to that specific module, and it will generate the Python code, and then it will give back that one. So that means there will be many models. They will be connected by another front model that will how to say that will integrate or organize those models and then generate answer and give it to you. So there will be many models. They will be connected or talking to each other, and based on their final conclusion, you will get the answer. Anything else?
Yeah.
I want to ask a relatively specific question. So
Yeah.
when doing the CNN, it's like a supervised training model, right?
Yeah.
So if we have a scene saying that I have a camera, I'm constantly capturing the scene, and I want to identify if there's a fire, then I want to identify is a fire,
Yeah.
and then automatically to send the alert to people.
Yeah.
So in that case, whenever I have a picture, how should I do the training the model, saying I want to identify the object in the picture?
Yeah.
So I don't know. I do not have predefined activity
Yeah,
It's
yeah.
predict. So in this case, how should I to do the
Yeah.
it's like
Yeah, okay.
unsupervised?
So there are two things. One is unsupervised. So in the unsupervised, you use it is called actually anomaly detection. I have a couple of papers on that as well. So you train the model using normal data. So you constantly taking pictures, right? And so the model knows what the normal picture looks like. And now if something happens suddenly, say fire, it will see that there appears something that is different from other pictures. And then because of this difference, it will generate an alert. So this is one kind of training that you can use, and it is unsupervised. But for some field, if you have some label data, say you have some pictures that has fire, some pictures not fire, and then you can use both pictures to train the model, and that will be supervised. So usually supervised model is more accurate than the unsupervised ones.
Okay, but the thing is like when we trying to predict the object in the future, so we don't know what's going to happen. There might be a fire, or might be rain, or whatever, a bomb.
Mhm.
But so I mean,
How-
there's so many variables.
Yeah, so how do you?
Way to narrow it down.
Yeah, so one solution can be you have a model that will only predict or identify whether something is different happening. So that will say, okay, this is it looks like something different. And it will take that picture and send it to another model where it will classify whether it is fire, whether it is bomb or something else. So you have two stages. One is a unsupervised model that will only detect something is different. And then you have supervised model that will classify that into different classes. So based on that, you know what is happening. Or you can ask someone to, if something happens, it will say, someone will look into the picture and see what is happening, right?
Okay, so another question. So when we're trying to abstract the object in the picture, like how should we do, for example, this just, I have to predefine the norm of the picture, or?
You don't need to predefine anything. If you predefine, then it is actually traditional programming. You don't need to predefine. You just give some data, that's it. Now model will learn from it.
Okay, so the key thing is that I have to predefine the normal thing,
Yeah.
like what.
You just take lots of normal photos, that's it.
Oh, okay.
Yeah.
Okay, thank you.
Anything else?
So, how do you train the first QMS model?
Yeah.
And how much data did you enable before it reached to a level that is satisfied?
Okay. So it depends on different domains and tasks. In our case, so because they are large documents, we had like a couple of thousand documents labeled. But because we splitted those documents after labeling, we had more instances. If each document is split into say 10 sections, and then you multiply those number of documents by 10, so you have more instances. But if you're training something, it is around, you're looking for 10,000 instances usually. Is that acceptable? Yeah, 10,000.
Yeah, because in your case, I think that your model performs a lot better than ChatGPT.
Yeah, accuracy. Yeah, because we had like quite a number of label data. Actually, for labeling, we had another organization. They are actually specialized for that task, and then they did the labeling.
Right.
Yeah.
So it actually like take some manual work.
Yeah, it was a one-year project, and we had 3 organizations connected to do this. There are a lot of things. I'm just giving you very gist, but there are a lot of things. Yeah.
That's very cool. And also like the large language model, like is that a logic layer to guide it somehow?
No guide, but it is possible. There are something called machine informed neural network, where you can actually, beside training from data, you can impose some rules or things. So for example, physics, if you are trying to predict whether an apple is rotten or not, right? You can take a picture that can be used as data to predict whether it is rotten or not. Another thing is you can actually take the moisture of the fruit and send that to the model and see if the moisture is something to lower than a threshold, maybe that it is rotten. So you can add extra rules there, and it is possible. In general, large language model, no rules, nothing. Just simply lots of data, that's it. Anything else? Okay. If not.